I'm going to go over domain and range of 5 different parent functions, starting with the linear function on the screen. This is the equation y equals x. It's just a line, slope of 1. This is the linear parent function. I'm going to show you the domain and range using this graph. Now, domain is all of your x values, and the way that we describe the domain would be naming all of the x values that exist on this line, starting on the left and working our way to the right. We always want to go from least to greatest. Now, if you just look at what's on the screen, the farthest left looks a little more than -6. And then if we move to the right, it looks like the line stops at about 5.5. But this is not the entire line. This is just how far it's zoomed in. If I zoom out on my screen, you can see that this graph is still here, not moving anywhere. There is no end. You can see that the x-axis numbers are getting a lot bigger, y-axis numbers getting a lot bigger. Now I'm in scientific notation because there's not even enough room for these numbers. So you can see that I'm trying to find where this line ends on the left-hand side of the screen, and it just doesn't end. Same thing as I work my way to the right. Now with the range, that was your y values starting from the bottom and working your way up, because we always have to go from least to greatest. Again, if I keep zooming out, there is no end to this line. It's going to start at the very bottom as low as you can possibly think, and then it's going to work its way up. So on this screen, I have the interval notation for the domain and the range of our linear parent function. Remember, interval notation is not an ordered pair. This is not the coordinate -infinity, infinity. X is not -infinity, y is not +infinity. Okay? In the domain, this part right here is just saying the farthest left that I could possibly get on this graph is -infinity. That means it's never ending. There is no actual starting point that I can point out on the left-hand side of this graph. And then as I work to the right, again, there is no stopping point to this graph. It's going to go to the right forever. So I'm stopping at +infinity, which means we're not really stopping because infinity is never ending. Notice I'm using parentheses on either end because parentheses mean not included, brackets mean included. I can't include infinity because I can't give you a specific value of infinity. Therefore, you must always use parentheses when you're using infinity in your interval notation. So if you wanted to pause the video and read the little paragraph I have on the screen, go for it. Otherwise, I'm moving on to my next function, which is the quadratic function y equals x squared. So this is my parent function. There are no transformations done to it, just y equals x squared. Now, this one is a little harder to see. Okay, so I'm going to move it a little bit. Now let's start with the domain. Domain starts on the left, works its way to the right. It's all x values from the lowest possible x value on this graph to the highest. Now, if I zoom in, let's see if I can figure out the smallest x value on the left. Okay, you can see that this parabola is still going. It's slowly moving its way to the left, but it's going. So you can zoom in as long as you want. The parabola is going to get seemingly smaller and smaller. But as you can see, there's nothing stopping this on the left or the right. In other words, you can plug in whatever x value you want. That means I have the same domain here as I did with the first function. Now the range is going to be a little different. Range, we always start at the bottom and we work our way up. least to greatest. Now, looking at the screen, I can actually point to the starting point of this parabola. If I zoom out, you can see that this parabola does not exist down here in the negative y values. It does not exist until I hit a y value of 0. But after I hit 0 and I work my way up, like I did earlier when I zoomed out, you could see that this is going to go up forever and ever and ever and ever. Okay, you can see that it's getting wider and wider, and it's going up forever. Now, if we write this in interval notation, the domain, like I said, is the same as the domain for the linear function. It's going to the left forever, it's going to the right forever. There is no end to the x's that you can plug in. However, with the range, notice it's not negative infinity to positive infinity. I have a bracket at 0. The bracket indicates that 0 is included in this graph, but then we said that it does go up forever. So remember, the lowest that it goes, our starting point would be 0. The highest it goes would be positive infinity because it's going up forever. Another way that you can write this, I'm using y because range is y values, is that the range is all y values that are greater than or equal to 0. Sometimes that helps understand interval notation a little better. So again, if you want to pause the video and read the little paragraph, go for it. Next is the cubic function, y equals x cubed. I will make this short. It is the same as the linear function with the domain and range. So you can think of it as a line, as the linear function, but with a bend in the middle. Okay, you can see if I zoom out, nothing is going to stop it. I know it looks really narrow. I know it looks like it's not going to go to the left and the right forever, but there's nothing stopping it from going to the left or the right forever. So that's how you should think of it is there anything that's going to stop this on the left or stop this on the right? So again, domain and range are the same as the linear function. Next is the absolute value function, y equals the absolute value of x. This is actually going to be the same as the quadratic function. They look similar. Instead of a u, it's a v, but they do have the same domain and range. So with domain, again, you start on the left, work your way to the right. It's actually a little easier to visualize it with absolute value, that this does go to the left and the right forever. It's the same as the quadratic function, but again, a v instead of a u. And then with the range, remember, range starts at the bottom. Down here, there is no absolute value parent function. There's no graph here until I get to 0, 0. Once I hit 0, then I go up forever. And you can see that this graph does exist as I work my way up. It goes up forever. So in interval notation, again, it's the same as the quadratic function. You can plug in whatever x value you want, because domain is x. But notice range is all of your positive numbers. That's because when you find the absolute value of something, it is the distance from 0. So the absolute value of anything is going to be a positive number, which is why my range is all positive numbers. The last one I'm going to talk about is the square root function. Notice the square root function isn't existing over here on the left. This is going to be the only one that I talk about where the domain is not all real numbers. So domain, again, is left to right. If we start over here and we pretend that we're over here at negative infinity, right? This doesn't exist over here. at negative infinity. It doesn't even exist in the negatives at all. It does not exist until I get to the x value of 0. But then, if I follow it, you can see that nothing is going to stop this graph from going to the right. Same thing with the range. If I go down to the bottom, the lowest negative number you could possibly think of, and then you start working your way up, this graph does not exist until I hit a y value of 0. But then, if I keep moving up, nothing is going to stop this graph. Now, it's obviously out of the picture, but if I were to move this way, you can see that it's gradually, slowly moving up. So nothing is going to stop this graph from moving up. So this one actually has a domain and range of 0 to infinity. But be careful, because if you're going to write this a different way, domain is x values. So we would write that x is greater than or equal to 0 and range is y values. So those are your 5 parent functions and a brief explanation of their domains and ranges.